This project took about, well, actually I think I started about 91, 92, but I was originally sort of stimulated even to look at this whole thing of maybe a slightly different description of our solar system, our history, our mythology as well, or interpreting it in a slightly different way by, of course, Velikovsky, because I read Worlds in Collision, I think that was about 1974, and I thought he did a very good job of alerting us to unusual phenomena that have been described in human history, but I felt he sort of tended to cram everything into one disaster event, or two disaster events that he was trying to sort of present in his thesis. Basically what I'm saying is that you can explain a lot of phenomena, not just in the mythology and the legends in our history, but also in current physics, if we are in a binary star system, or were in a binary star system. And so what I've done in terms of this project, I sort of wrote a lot of stuff, and then I realized it's too long for one book, so I've split it into 3 volumes. So the first volume, Cataclysms and Renewals, is taking the sort of mythological and legendary descriptions of these, catastrophic events, and showing seems to be a repeating periodicity, which suggests an orbit. So whereas Velikovsky is talking about sort of a one-off event, Venus gets ejected from Jupiter, whizzes around the solar system, some bad things happen, but it's very much a closed drama. What I'm saying here is that this is a repeating process that's been going for billions of years, that we are in orbit with another object, and it flies in rather like a long period comet and flies out again, and it disturbs us, it doesn't hit us, but this is a sufficiently massive body that there's significant tidal effects when it comes through. I mean, I'm estimating this thing as about 10% of the mass of the sun. In the second book, which came out this year, what I've done is accumulated all the scientific evidence for this effect. And I'm starting at the weather. So I'm looking at climate history and strange periodicities in our climate history, because when people first studied climate, they thought there would be sort of a pretty stable natural pattern, and then along comes human-based climate change, and boom, something happens. In fact, what they found over, say, a 100,000-year period or 800,000-year period is this huge amount of volatility, and it seems quite periodic, and nobody knows what's driving it. So basically, I'll go into that in a bit of detail. I'm not going to say everything that's in the book. Read the book. I mean, there's a lot of information there. I'm just going to point out certain bits of information. And then the third book is in process right now, which is looking at history, not legends, but actual history and archaeology, because there's a sort of revolution going on right now about the duration of history, right? That up to maybe 50 years ago, people would say history is about 5,000 years long. But more recent discoveries and better dating techniques shows that certainly you can get objects and structures going back 12,000 years. So most recent discovery is the discovery of Göbekli Tepe in southeastern Turkey, and clearly that's a very old structure. Some civilization made it that we know nothing about. We seem to have this massive gap in history between about 3000 BC back to this period when they built Göbekli Tepe. Deepest levels of Jericho also have been well dated to be maybe 9,000 years ago, possibly 10 or 11. And then you can go in areas like Japan, where you can go back even further. You can find Jomon culture is 13,000 BC, and it goes on. So, and even we have ancient authors who talk about a history of 20,000 years or 40,000 years, not 5,000 years. Anyway, so that's what the third book's about. But I want to focus now, and I watch my time, on one item, which is a central feature of the whole idea, and that is the fact that our sun was born with a companion star. And this has now become hot physics this year because the evidence is piling up that most stars, if not all stars, are born in pairs or multiple systems. And they either lose one because it gets flung out of the system, or it's very big, so it burns up its nuclear fuel very quickly and just blows up. And in fact, that's the model I want you to think about when I'm talking about our solar system. So, and I'm not the person who did this, I'm not that clever. Fred Hoyle suggested this in 1945, I think 1950, where he said that there's a lot of evidence for a former companion star that blew up to provide the elemental materials that made the planets. the reason you need to think about a large star is because the nucleosynthesis cycle goes faster and faster, more material you have in one star. So a star of that mass doesn't live that long. It can live, a matter of maybe 100 million years at most. And you can observe very big stars now. They can go out to sort of 25 solar masses, but we know the astrophysics is quite well established. These things have quite short lifetimes and will end in a supernova. Critical idea, though, is that with Hoyle, he said, yes, looking at the planets, it looks like supernova debris has accumulated, formed planets. But he said the explosion probably just blew the remains of the star far away. It's gone forever. And the difference in my position is saying, yes, it was fired away from the sun, but it wasn't lost, and it's still in orbit. It's on a very long period orbit. There's about 4,000-year periodicity, which I want to go that way. Yeah. This is very nice pictures that came out 2 years ago, which actually still haven't been fully interpreted for what they show you. Now, when I look at that, I think that looks like a cartoon explosion, right? But I want to point out it's extremely big, because the scale is 1,000 parsecs in each direction, and that cross right in the middle is us, right? So we are right at the middle of what looks like an explosion structure. What you're looking at is the X-ray output of the tenuous atmosphere around our solar system, and far, far beyond. To really understand how big we're talking, like you can put Sirius and a few other local stars just right almost in the middle there on that scale. Okay, Sirius is only 8.6 light years from us. So that map is showing is X-ray output from the very tenuous atmosphere around our solar system in the galactic plane. And the other map is looking at dust, which is the dark patches, and these points that's showing on here are looking at the ionization of material in the line of sight of a particular star. So you imagine a starlight coming from a particular star, and stuff in between us and the star is absorbing that light, and therefore you can measure the ionization of the gas in that, basically that sort of tunnel. Now, in doing that, you can work out there's a preferred direction where there's ultra-hot gas and very rarefied gas. And there's this definite symmetry, and that's what this big arrow is showing. And what I'm proposing is, this is the remains of our supernova explosion 4.6 billion years ago, and that big arrow is pointing to where the star core went. Because basically what I'm saying is, this is all the dust going that way, like the exhaust of a rocket, and the old remains of the center of the star went that way, right? And what's fascinating is that picture ties up beautifully with the mythological descriptions of where, all the the godlike beings like Xeus or Horus or any of these people are supposed to be residing in the sky, which is basically between Sirius and Orion. And going back to some other famous authors here, there's this focus on Orion and that region of sky generally in ancient Egypt. So what happened after that supernova explosion was the convective layer of the star blew off, and the central part of the star collapsed in on itself. Now, if you have very large stars and they don't lose a lot of mass, they become neutron stars, or they can even become black holes. I'm saying in this particular case, our supernova blew off enough material that it only left a core that's sort of a mass of a white dwarf size object. And the reason I'm saying that is because if it was a neutron star, we'd be able to see it really easily because it would have a massive X-ray output. However, this object is not just important for the model, it's also important for us as human beings, because it actually opens the door to understanding another mystery, which is the extremely rapid origin of life. Because, without spending too much time, origin of life in 5 seconds. Okay, the big problem with the origin of life is how fast. It clearly happened on this planet. And it's an incredibly improbable process. What I'm saying is that you need circular polarized UV light to synthesize material in space. So what I'm saying is, the star blew up. That's a process where you're getting a lot of nuclear synthesis. You're getting a lot of carbon, nitrogen, oxygen. In fact, when stars blow up, you get all the basic materials of life, the basic elements that are common in living systems. But then when it starts to cool down, and if you've got lots of UV around, particularly circular polarized UV, you get synthesis. So you get chemical synthesis going on in space. So I'm saying the origin of life was not, a few lightning flashes in the atmosphere of Earth, but an absolutely massive chemical pot that was going on in the solar system. And what landed on Earth was not, just a few gases. I mean, the macromolecules, crude oil, all that carbonaceous material we've got on our planet is not the result of biology in a later era. It happened as a result of this explosion. You can read about it, it's all in the book, in the appendices. But the critical thing I'm saying here is that the characteristic for able to produce that type of light, you've got to have a magnetic core, old magnetic star core, and that makes it detectable. And I have detected it, and that's what's on the front cover of that book. All right, that's actually this infrared output, but the big signal you get is in fact it's radio wave output because of its electrical and magnetic fields. Okay. Bit of, again, quite popular modern discussion, which is the January 2016 Caltech sort of announcement about Planet 9, right? Planet 9 is predicted because there's strange patterns of perturbations in the outer bodies of the solar system and the Kuiper belt. Now, what's very interesting, if you look at their data, this is all their perturbation orbits, all right? Scattered objects on the edge of the Kuiper belt, they're in exactly the opposite direction to where I'm saying, all right? So I'm saying that as the star core comes in, it disturbs the orbits of all these objects out at about 50 astronomical units. Because you've got to remember, when you have two massive objects like the sun and an object outside the solar system, we'll orbit like this. So we, as a whole solar system, are moving. Right? Now, one of the other things I thought, okay, how can a whole astronomical community miss this one? Well, they probably didn't. It's probably in the data. So I had a quick look at the data. And I don't know if you're aware of this, but the way we look at whether other stars have planets is because you can look at the shift in the spectra of the stars because they're wobbling, okay? So you get some spectral shifts in the line spectra. Well, you can apply the same logic to us, right? So if we're moving, we're going to accelerate, we're going to have wobbles, and you can look at the light coming from the star in the same direction where we should be traveling. Now, it so happens that Sirius is a nice bright star, is pretty much in the same location where this object's located, and you can look at papers, scientific papers from like around 1900, around 1920, around 1950, because people have measured the radial velocity between us and Sirius. Now, one of the unusual things about Sirius is it's actually coming towards us, or we're coming towards it, right? That's unusual. Most stars are redshifted, they're going that way, so it's blue shifted. But that's nothing interesting, because it could just be random scatter. What is interesting is we're accelerating towards it. That means we're falling down a hole in that direction, all right? And that means something dark out there is attracting us in that direction, okay? All right, I'm going to jump now to sort of Velikovsky a bit, because it's very relevant to this society. Okay, Velikovsky says sometime in the deep, well, not the deep past, maybe 10,000 years, Jupiter ejected Venus in some process we don't understand because it doesn't fit with current ideas of planetary physics. I'm saying something slightly different. I'm saying we had the sun and this star core. Venus was actually orbiting as a satellite around the star core, but 12,000 years ago, a coincidence of events meant that it got captured by the sun, a much more massive body, and the reason Venus is so hot is it actually had quite an elliptical orbit around the star core. Now, again, this is not weird physics, this is absolute fact. For example, you can look at Io, a moon of Jupiter, also has quite an elliptical orbit and gets very hot because it's getting squeezed all the time as it moves closer or further away from Jupiter. So I'm saying that's the origin of the heat of Venus. The capture event happened 12,000 years ago, coinciding with the end of the Ice Age, because in that process of Venus getting captured, we had a flyby of the star core, we had a flyby of Venus, and it shook us up very badly, and massive climate change, a lot of reorientation of the planet. And so that was the big event that brought Venus into the solar system. And then the one that Velikovsky talks about is, well, I'm calling it the cataclysm of fire. So this is, okay, Velikovsky, I'm moving the dates around a bit because there's climate data to show an event in 1628 BC. I think Velikovsky goes 1400 BC, but it doesn't matter. There's data to show something big happened in 1628 BC. Now, most people say, oh, it was just Santorini blew up. This is the island in the Aegean, Mediterranean. And but in fact, it's a worldwide event. You can look around the geological record and you can find lots of things that were going off in 1628 BC. It wasn't just in the sort of eastern Mediterranean. So in that event, I'm saying that's when because in 9600 BC, the star has a highly inclined orbit. Venus had a highly inclined orbit when it was captured. So you've got to work out how can you get from a highly inclined orbit to a coplanar orbit. So you've got to have some type of gravity assist turn. And unfortunately, we were the sort of the pivot, and that's what shook us up. And that's how Venus gets into this sort of coplanar orbit. But there's another little bit of mythological data where the Aztecs were always fascinated by the fact you could see, if you could see Venus in the same place as the Pleiades at midnight, you're in trouble. The point is, it's impossible for Venus to be in the direction of the Pleiades at midnight if it's in a circular orbit. The only way you can do that is if it's in a highly eccentric orbit, which is stretched out in that direction. So in fact, it's going out beyond the Earth because the sun's behind you, right? It's nighttime, and you're looking out in the opposite direction, all right? So anyway, so that's that event. I'm watching my time. Okay, and then the other Velikovsky event, again, he's doing in the 8th century. I'm saying, no, this is about 1150 BC, because again, we've got good data, something happened in that time. You've got a complete wipeout of late Bronze Age civilization, well dated. And in that event, we had Venus in this sort of coplanar orbit, but actually crossing the path of our orbit. And then, again, there was this exchange of momentum. We got too close to each other. But in fact, that's what circularized Venus' orbit. And the final picture is a Venus Express photograph, because Velikovsky had a lot of problems with people saying it's absolute rubbish, it was never a comet. But it looks like a comet. That's a real photograph. That's what it looks like. It looks like a comet. And there's actually a lot of material and dust at the orbit of Venus. So it's not only is it shooting out this huge amount of gas and dust, but actually the whole orbit of Venus is just a ring of material where Venus has shed a lot of material very recently. Okay, so that's, in conclusion, read the books, right? Cataclysms and Renewals is the sort of mythological, legend-based argument to come to the conjecture that we have a star core in orbit. Star core Xeus is the science, and looking at a lot of things, not just the astrophysics, but I'm in fact, just going back to the previous talk, there's a huge amount of evidence for the nucleosynthesis in stars. Yes, there are electrical processes going on in stars, but the actual process, the way stars born and die and the materials they produce is absolutely well established. There's a huge volume of data to support that. I'm not saying there's no electrical phenomena. There are electrical and magnetic phenomena happening in the solar system, but dominant force is this nuclear process. And I also focus on, in the books, looking at things like, okay, why do we have the moon we have? Why are our continents actually the crust? They basically are crustal materials. They're very old. I don't know if you know this story, but the ocean floor is no older than 250 million years. You can't, in fact, the oldest bit of ocean floor that's certain is about 190 million years old. You can't find any rocks that are old on this ocean floor. You drill around on land, you will find 4 billion year old rocks or 4.2 billion year old rocks. Point is, land is the old surface of our planet. Ocean floor is the repaired surface of our planet. The material that was pulled off the planet was the moon. But the thing is, to achieve that, you need something extremely massive, getting very close to us. But I've calculated, and I've got some Russian friends, Russian physicists, in fact, who help me, is without doubt, if you do a flyby at 400,000 kilometers with an object the mass of the sun, 10% of the mass of the sun, you will actually take the crust into orbit, because you have a very fast flyby. And you can calculate, it's a doable calculation. And so, I don't know if you're aware of this, but I think it was 2013, the Royal Society convened a meeting about origin of the moon, because there's lots of conflicting data out there. We don't have any model that fits what the composition of the moon is all about. I mean, both the atomic level and also the structural way it's put together. It's very consistent with it being like our planet got peeled like an orange, or half of it did anyway, and it crumpled up, and that's how it got into orbit. Anyway, that's in the book too. So lots of stuff, but I can't talk anymore because it's now 12:30.
Thank you. That's going to get everyone thinking. Have you got enough time in terms of the momentum that things to get it into a very circular orbit around the sun from this peculiar orbit?
Well, it's without these sort of dramatic sort of gravity assist turns. I mean, you're probably aware the way we fling the spacecraft around the solar system is that we push them close to Jupiter, it then whizzes it round in another. You can actually change the plane of the orbit of it. When you launch a satellite from Earth, you have this problem that's basically in the ecliptic plane. So you've got to, if you want to get like a SOHO spacecraft to go over the sun, you've got to whiz it around another planet and do that. So I'm saying all of this sort of orbital change requires another massive body. So in this case, it was close interaction between Earth and Venus, and you can't just shift Venus move it into a new orbit without doing that to us as well. So there's relative masses involved. So
it's a bit of a coincidence that Venus ends up in exactly central orbit around the Sun on the.
It's absolutely true. That is its orbit. It has an unusually circular orbit, but how that circularization happened was a result of this turn. But you can say it's a very improbable turn, but you can do it. It works.
Have you, in your research, accessed any of the SI's material?
Yes. I mean, you guys stimulated me well through. I mean, I think I first started getting your journals in the 90s because the first thing I looked at Velikovsky, and then I looked at some of the work that was going on with people talking here and writing, on different subjects. So yes, definitely, it's been very helpful.
You're suggesting, I think, that the moon came from bits stripped off the Earth.
Yes, I'm saying it was the.
If that's the case, when did it happen? First question.
Right. Okay. Very controversial answer I'm going to give you. 250 million years ago. It happened at the same time as the Permian mass extinction.
Now, that would make sense, except there is not a cell in my body that believes that ancient man would have completely ignored the existence of the moon, talked about planets, but no bloody sign of the moon.
Hang on. I said 250 million years ago. Ancient man has been around, well, what we consider modern man, maybe 200,000 years, maybe 100,000 years. Yeah.
What I'm saying is, if the moon was the companion that it is today,
yes,
not a single cell in my body would believe that ancient man, even if he is only 25, 50 or a million years old, would have said absolutely sweet FA about it.
Right, okay.
And then suddenly it comes on, and as Velikovsky said, there are peoples who say before the moon.
Okay. Well, okay. I haven't come across a clear story of that kind, so I'll look at it and see. I'm not sure. The Aborigines say there was no moon at the time. Okay, that's possible.
Thank you.
Okay.
Well, that controversial talk.
Yeah.
I think it's just about time. 1 minute early to go to lunch.
Okay, thank you very much.